Our next speaker is Vladimir Pushmin, who's the Chief Product Officer at Arloid Automation. He's responsible for their global sales, marketing, and partnerships as well. So over to you, Vlad.
Great. Amy, thank you very much for the introduction. Hello, everyone. It's nice to meet you all. So today I would like to share some insights into COVID-19 impact on buildings' energy consumption, and also touch on how artificial intelligence can help to achieve the net zero. So since the start of the lockdowns in different parts of the world, the average electricity demand dropped by around 15 to 30% in the first 20 days. And which is something you can see here in April, but also throughout 2020 until December, we can also see a bounce back in electricity demands in the same parts of the world. And specifically in China, everything started to come back to normal at the time when the rest of the world started to go for lockdown, and currently they show 7.5% increase actually in the monthly electricity demand year to year. And so within the building sector, the lockdown caused a shift of energy consumption from one type of buildings to another type. So specifically, the residential buildings showed increase in energy consumption by around 8%, which significantly impacted on the workloads for data centers. While commercial buildings showed a negative trend, since shopping malls, hotels, office buildings, restaurants, and all of that, they were closed, which basically significantly also varies from one country to another. And so touching on data centers between February and April, there was a 38% increase in total traffic growth, which mainly came from the increased use of online communication tools, video streaming, gaming, and social networking. And also some key players in the data centers space say that they're currently operating at demand levels that they expected to see in 2023, and that there is also a 17 times increase in the willingness of enterprise customers to migrate to the cloud. And so in this case, as a result, it increased massively the workload for data centers, and hence increased the energy consumption for them as well. And so while commercial buildings experiencing less occupancy rates in some part of the world, it's actually a great opportunity for building owners to go for the upgrades of their buildings. And so there are some ways to do it, and one of the ways is to go for upgrades of the existing infrastructure, which is great if it's absolutely necessary. However, it requires heavy upfront investment. It's time consuming and also has a long ROI. And another way is to go for the adoption of machine learning techniques that might help to upgrade existing systems, existing infrastructure, to make it smarter. And one of the things that artificial intelligence can target with regards to problems is static management of heating, ventilation, and air conditioning settings in real estate, which usually accounts for 50 to 60% of total energy use of buildings, depending on the region again. And when we talk about the static management, we mean that operations team tend to rely on tenant complaints and rarely change settings or rely on predefined schedules. And so while the environment inside and outside of the building is changing dynamically, and so if these changes are not addressed, it leads to a massive energy waste and also carbon footprint. And so here Arloid comes into the picture, and we developed an AI solution that automatically changes HVAC settings based on comfort index calculations in real time. So the way we work is that we connect to the building within 2 hours using fast and non-intrusive way without deployment of any sensors. Then we run a building simulation for building, which is meant to show the potential for optimization, the baselines, and also the insights on how exactly artificial intelligence is going to achieve that. And also as part of the simulation process, we separate the building by different zones, establish unique comfort indexes, since different spaces within the building might require different levels of heating or cooling. And then when we initiate the pre-trained AI in the building, it is tasked to satisfy these unique comfort indexes in different spaces by choosing the least energy consuming HVAC settings. And from buildings that we work with at the moment, we see that artificial intelligence can go for the change at the same time for 500 devices, for 400 devices, up to 1,000 devices. And in this case, it is practically impossible to execute that manually, while artificial intelligence is the best kind of way to achieve that. And so with such an approach, we're looking at up to 40% optimization on the cost of energy, cooling, and heating. It's around 30 to 40% decrease in carbon footprint, and also a significant improvement in the comfort of occupants in buildings. And all of that can be achieved without any capex, since we utilize existing infrastructure of the building, and also building owners can go and pay to us based on confirmed savings on monthly basis. And so just on a closing note, I wanted to say that achieving net zero requires a collaborative effort from devices manufacturers, from BMS providers, from companies that manufacture construction materials and providers of sustainable energy sources, etc. And artificial intelligence here is just a part of it, but this is a part that helps to move closer to achieving net zero easier, faster, cheaper, and most importantly, in a safe manner. Thank you.